All right, so today we're looking at the quotient rule. Remember, a quotient is the answer to a division problem. So the quotient rule tells us how to take the derivative of a ratio of functions. So when you have a variable in both the numerator and the denominator, you have a quotient of functions. You can think of it as f of x over g of x. Notice, we've got f of x on top in the numerator, g of x in the denominator. The quotient rule says that you take the derivative of the numerator times the denominator, and I'm just going to highlight when it's just exactly the same, no derivative, minus the numerator times the derivative of the denominator over the denominator squared. So I've highlighted what's actually just the plain old function as is. Notice the order that we write this in. We have f of x, g of x, f of x, g of x, right? So derivative of the first, or derivative of the numerator, times the denominator, minus, you see f of x is first again, and then it's derivative of the second one, right? So if you think alphabetical order, however you want to remember this thing in your head, it should be pretty straightforward because we've set this thing up to kind of make sense in ways other than math, right? And that's pretty important when you're trying to remember a formula. Of course, you can prove this formula as well. That's not what today's video is about. It's about looking at the actual rule and then an example of that rule. So let's look at an example now. So if we had that f of x was equal to 4x cubed plus 9x squared over 2x to the 7th minus 4. Let's see what happens. So what I'm going to do, I'm going to kind of like use some colors again just to point out what's happening here and hopefully be able to track this thing a little bit better. So I'm gonna just try to remember that I'm assuming my denominator is blue, my numerator is red. In fact, I'm probably going to just rewrite that now to make it a little neater and easier to see. So I'll say 4x cubed plus 9x squared. That's our numerator. The denominator is 2x to the 7th minus 4. Right, so there's my f of x. And I've just rewritten it that way so it's a little bit easier to see. Okay, and then track when I take the derivative. So if I'm taking the derivative of that, if I'm finding f prime of x, the very first thing is the derivative. Look, the derivative of the numerator, right? So the derivative of 4x cubed plus 9x is 12x squared plus 18x. I'm going to put that in parentheses because we all know we're then multiplying by the denominator. So I need to multiply by 2x to the 7th minus 4. And then my quotient rule says to subtract, right? It's the difference. And now it's just f of x, right? Whatever that numerator was. So 4x cubed plus 9x squared. And we're multiplying that by the derivative of the denominator. So if the denominator is 2x to the 7th minus 4, its derivative is 14x to the 6th. And of course, the derivative of negative 4 is 0. So we don't subtract 0, we just leave it off. So there's that numerator. I've got this whole expression written out, but I have to remember that I'm going to divide that whole thing by the denominator squared. Well, what was the denominator? Just 2x to the 7th minus 4. So there I have it. My derivative of f of x started out this crazy function, right? A ratio of 2. And I can actually do that. I can find its derivative, which is a function that explains the rate of change at any value of x.